Hello, Hornets, and welcome. Today, we're going to be taking a look at related rates of a conical tank and of a circular shaped puddle. All right, so here we go. Let's just get started. All right, so we're going to start with this problem. A conical tank with vertex down is 10 feet across. Let me just zoom in on that a little bit. There we go. Is 10 feet across and 12 feet deep. Water is flowing into the tank at a rate of 10 cubic feet per minute. Find the rate of change of the depth of the water when the water is 8 feet deep. Now, I recommend that you start by drawing a picture. Pictures are important to us. We find, or you should find, that they're helpful. Lets us gather our work together and keep things organized. Now, I am told that the total is diameter of the cone at the top is 10, which makes this radius equal to 5. And let's make sure we include our units of feet. And we know our height is 12 feet from the 12 feet deep. Well, we're going to start off by setting up a similar triangle. I'm going to put a random R and a random H. And from this, I can now come up with some relationships that I can work with. For example, if 5 is to 12, then R is to H. And we know that from geometry. Therefore, R has to equal 5/12 of H. H has to equal 12/5 of R. Now, keep in mind that it becomes a choice of whether we want to substitute into the formula right here, R or H. You'll notice they give us the depth, they give us the rate of change of the water coming into the tank, and they give us that's it. That's what we got to find. We got to find the rate of change of the depth, and that's H prime. So you'll notice if I take my derivative now, I'm going to get this very ugly v prime equals 2/3 pi r h r prime plus 1/3 pi r squared h prime. That's a fairly ugly equation. And I recommend that we find a way to substitute and get it cleaner. For example, if I take the original equation, v equals 1/3 pi r squared h, and I replace what r is, then everything is in terms of h. I'm just going to put my 12, whoop, that's wrong. We want the 5/12. Let's make sure we replace what r equals in terms of h. So we have 5/12 of h squared times h. And you'll notice that I end up getting 1/3 pi times 25 over 144 times, and now I have h squared h. I'm just going to go ahead and clean this up to be 1/3 pi 25 1/44, and I have h cubed. Now you'll notice, when I take this implicit derivative, I get v prime. The 3 comes down, getting rid of the 1/3, and I end up with 25 pi over 144 h squared h prime. Now, notice, we know that our h is 8 feet deep. We know what v prime is. V prime is 10 cubic feet per minute. Because water is going into the tank, we know it's filling it up, and therefore it's a positive value. So 10 is going to have to equal 25 pi over 144 times 8 squared h prime. Now, if I now solve for h prime, so you can see I'm going to have 10 times 144. Denominator is going to be 25. We have 8 squared and pi. That's equal to my h prime. Make Sure you can see that clearly. And now I have to solve. Now I've already taken the opportunity to find out that h prime is going to equal 9 over 10 pi, and I'm going to include my units, feet per second. Let's just review what we did. The product rule is too ugly when working with the volume formula, so we wanted to get rid of that complexity. To get rid of the complexity, we either find what h or r equals depending upon what we're solving for. Since I'm solving for h prime, I want to get rid of the r. So for every r, I put in 5/12 h. And that's what we've got right here. I then go through the process of simplifying it and taking my implicit differentiation and plugging my values in. I then solve for h prime. That's a related rate with a cone. Let's take a look at another problem. This one is with a circular pond. Water slowly evaporates from a circular pond, circular-shaped puddle. The radius of the puddle decreases at a rate of 5 inches per hour. Decrease means it's going to be a minus. Assuming the puddle retains its circular shape so that we have a consistent change, at what rate is the area of the puddle changing when the radius is 9 inches? Once again, I'm going to start with a circle, picture. I have my radius, 9 inches. I'm just going to put r prime is negative 5 inches per hour. Well, what's the area of a circle? Area is pi r squared. So implicitly, in terms of time, a prime is equal to 2 pi r prime. I know what various pieces are, so let's put them in. A prime is going to be 2 pi times the radius 9 times the change in the radius minus 5. Well, all I have to do now is simplify to find my answer. And you'll notice I have 45 times 2 is negative 90 pi, and this is the change in their area, so it has to be inches squared per hour. This is how we find a related rate for a circle. I hope this has helped you, and please remember that when you're doing these, start by drawing a picture. See if you can replace any values from a relationship that's in it based upon similar triangles. Then, find your implicit differentiation regardless of what you have. It might be a product rule, it might be a quotient rule, it could be the chain rule. Then plug in the values you know, making sure that you find any values that you can through the normal processes of a Pythagorean theorem or whatever relationship they gave you. And then finish by solving for the missing variable. You want to write your answer as a sentence, and then you're done. Alrighty, that's an example of working with related rates. I hope it has helped you, and I hope that this sees you well. Please be safe and be kind to each other, and we'll be talking more about these throughout the next couple of weeks as we keep working with related rates. Remember, you have to practice in order for it to be successful. Thank you very much. Be well, be safe, and take care. And please remember to be kind to each other. Change starts from within. We can't expect the world to change if we aren't going to change ourselves. Thank you very much, and please take care. Bye-bye now.